If you've ever found yourself staring at a screen full of, technical jargon namespaces, epics, runners, webhooks, and just felt your brain seizing up, you are definitely not alone.
Mm-hmm.
Whether you're prepping for a certification, maybe onboarding with a new DevOps team, or just trying to figure out where your code actually lives, understanding the language of a platform like GitLab is, well, it's the key to competence.
It is, exactly. And technical jargon isn't just a vocabulary test, it's a structural hurdle.
Right.
When terms that sound similar, like a branch versus a fork or an issue versus an epic, are used interchangeably, it completely undermines your understanding of the system's architecture.
It muddies the water.
It really does. So what we want to do today is, cut through that noise and give you a structured review. Our mission is to move past just surface-level recognition and provide the deep, functional knowledge you need to start applying these concepts right away.
That's the mission. We've compiled the key source materials, all the documentation and best practices that define this ecosystem, and we're distilling it for maximum retention. We're going to tackle this in 3 logical, progressive layers. We'll start with the foundational organizational structure, then move into the planning tools that track the work, and finish with the collaboration and automation mechanics that really power GitLab.
Sounds like a plan.
Okay, let's unpack this. We have to start with the absolute foundation, the hierarchy. I mean, if you can't define where the work happens and who owns it, the rest is just noise.
Completely agree.
So let's define the core trio that establishes that organization.
You must master these 3 building blocks: namespace, project, and group.
Okay.
First up is the namespace. Think of the namespace as the primary unique identifier. It's the address, the home for either an individual user or a top-level group.
The home. I like that.
Yeah, every resource you create, every project you build, it has to live under a namespace. It anchors the ownership.
So if the namespace identifies the owner, what's the project then?
The project is the core engine room. This is the central repository where the actual application code, its corresponding issues, and the specific CI/CD pipelines all live. A project is typically dedicated to a single application, a service, or a deliverable.
Wait, okay, if the namespace identifies who owns the projects, why do we need a separate organizational element called a group? I mean, doesn't that just add complexity?
That's where the architectural insight lies. And it's a point where newcomers, they often stumble. The group is the crucial organizational layer that collects related projects.
Okay.
While namespaces identify ownership, groups define management and access. And here's the crucial takeaway, and this is something you should absolutely look out for in any assessment. Groups are the mechanism for permission inheritance.
Permission inheritance. So it's not just about sorting things into folders.
Absolutely not. It's the security and efficiency layer.
Hmm.
If you are a member of a group, you automatically inherit the necessary permissions across all the projects nested underneath it.
Ah, I see.
This means managers don't have to manually update permissions for dozens of individual projects. They just define access once at the group level, and that access cascades down.
So it scales.
It scales. Understanding that inheritance mechanism is fundamental to correctly using GitLab's access controls and defining your internal team structure. It tells you that a group is a policy boundary, not just a label.
That structural definition helps tremendously. Groups are the security layer, projects are the code containers, and namespaces define ownership.
Exactly.
Now that we know who can access the code, the next logical step is figuring out what work they are supposed to be doing. Let's pivot to planning and tracking the workflow.
Right. We move from organization to workflow management, and here we're dealing with scaling work, from the smallest fix all the way to the largest strategic goal.
Okay.
We start with the smallest atomic unit, issues. Issues are the fundamental element for tracking work, bugs, feature requests, or tasks. If it's a discrete thing that needs to be done, it should be an issue.
And once you have hundreds of issues, which, let's be honest, inevitably happens,
Well, it always does.
you need a way to sort them, prioritize them, and find them quickly. And that's where labels become essential.
Precisely. Labels are the mechanisms used for flexible categorization and filtering. And you apply labels not just to issues, but also to merge requests.
God.
Labels allow you to filter by team, by priority, by functional area, or even by CI/CD status. They provide immediate visual context across your entire task board.
Got it.
Now, when those tasks start adding up, you need a way to manage scale. And that's where we introduce epics.
Right.
Epics are used for those larger multi-month initiatives that require collaboration across several projects and teams. An epic serves as the container for dozens of related issues.
So epics are for the What big strategic goal are we accomplishing this quarter? And issues are for the which specific bugs and features will get us there.
That's the perfect distinction. But here's a common mistake we see in application. Organizations sometimes use epics for tasks that are really just, 2 or 3 issues long.
I've seen that.
Right. When you use epics for small tasks, you ruin your high-level visibility. Epics are designed for large initiatives, where tracking 50 issues against one strategic goal makes sense. Misusing them just muddies the water.
Scope management is everything. Okay, so you track the big initiatives, the small tasks, but you also have to track against time. How do we keep everything tethered to a roadmap?
We use milestones. Milestones are time-bound buckets. They're defined specifically as a way to track a collection of issues and merge requests toward a specific target date, like the end of a sprint or a major product release.
Okay, so a deadline.
Essentially, yes. They provide that clearly visible marker on the roadmap.
And circling back to our architectural definitions, we know group and project are different levels. What level do milestones actually operate on? Does a project milestone control the entire group?
That is a critical detail to master. Milestones are available at both the group level and the project level.
Okay, both.
And this flexibility is powerful. If you have a cross-functional team where 3 different projects need to coordinate their release on the same date, you define a single group milestone for them all to target.
Oh, okay.
But if one small internal service needs a specific patch date that's unrelated to the main release, that project can use a project milestone. The key insight is that a group milestone sets a schedule for an entire collection of related projects, offering that enterprise alignment.
That clarity helps tremendously in setting up a scalable planning workflow. We've organized the people and the tasks. Now let's move into the code mechanics and the collaboration tools. We need to define the difference between sort of the foundational Git elements and the added functionality GitLab provides.
Okay, let's do it. We'll start with the fundamentals of Git, which are universal version control concepts. We have commits, which are simply those historical snapshots of changes to your code.
Right.
Then we have branches, which are parallel lines of development within the same code repository. They allow multiple developers to work independently without breaking the stable code.
Speaking of parallel development, and this is a classic exam trap, you must be prepared to distinguish between a fork and a branch. What is the core difference between those two concepts?
Great question. Because they both involve copying code, but their purpose is entirely different. A branch is an internal operation. It's a line of work meant to be merged back into the repository it came from.
Okay, internal.
A fork, on the other hand, creates an entirely separate new copy of the repository that exists under a different namespace. It's an independent copy designed for external contributions, like when an open source contributor wants to experiment on a project they don't have direct write access to.
So branch is collaboration inside the house, and a fork is collaboration with the outside world.
Exactly. That separation between internal parallel work, the branch, and external independent copies, the fork, is vital.
Okay.
Now let's talk about the structure GitLab wraps around that basic branch concept. The merge request, or MR.
The MR, right.
The MR is the beating heart of collaboration in GitLab. It's the formal process wrapper around merging branches. When you finish work on a branch, you open an MR.
And this is the spot for review.
It's the single location where you propose code changes, trigger automated quality checks, invite specific reviewers, discuss feedback inline, and ultimately gain approval to merge your branch into the stable code base.
So the MR brings the code changes and the process management all into one centralized spot. What about auxiliary tools that make that collaboration process faster?
Right, so we have the Web IDE. This is a powerful integrated code editor right inside the GitLab interface.
Yeah, that thing is useful.
It is. If a reviewer spots a small typo during an MR review, or if you need to make a quick configuration fix, you don't have to pull the code locally, open your desktop IDE, commit, and push.
You just do it right there?
You do it all right there in the browser, streamlining those small, rapid fixes.
Okay, what else?
And then there's the snippet. This is often overlooked, but it's highly useful. A snippet is defined as a small piece of code or text, specifically for sharing outside the structure of a full repository.
Like a gist.
Exactly like a gist. Think of a quick, shareable piece of documentation, a unique configuration block, or a helpful SQL query example.
And do snippets follow that critical level distinction we talked about, group versus project?
They do, which affects their visibility and utility. Snippets can be project scoped, meaning they're tightly relevant and contained within that project's context.
Okay.
Or they can be global, meaning anyone across your entire GitLab instance can access that piece of shared code. That scoping choice determines how widely you want to broadcast that information.
Okay, here's where it gets really interesting. We've defined the structure, the plan, and the collaboration, but the whole point of DevOps is automation, continuous integration, and continuous deployment, CI/CD.
The engine.
This is the engine of the entire platform, and it often sounds complicated, but I think we can simplify it with a great analogy.
Let's use the brain and body analogy for CI/CD because it clearly defines the separation of concerns.
I like it.
The brain is the configuration file, the .gitlab-ci.iml file.
The YML file.
Right, this YAML file is the brain because it contains all the instructions, the configuration, the blueprints for what should happen. It declares which tests to run, what artifacts to build, where to deploy. It is the declarative source of truth, but it doesn't do anything itself.
Okay, so if the YML file is the instruction manual, the body is what actually performs the physical labor, what executes those instructions.
That is the GitLab runner. The runner is the agent that actually executes the jobs defined in the CI/CD pipeline.
That's the worker.
It's the worker, the computational resource. When a change is pushed, the YML file tells the CI system what to do, and the runner fetches the code, receives the instructions, and then performs the commands on the underlying infrastructure, whether that's a virtual machine or a containerized environment.
So that distinction between config and execution is vital. What happens if the YML file, the brain, tells the runner to do something the runner's infrastructure can't handle, like? Maybe it asks for a specific environment variable that doesn't exist on that host.
That's exactly why the separation is key for troubleshooting.
Mm.
If your pipeline fails, you immediately look at two places.
Okay.
Did the brain, the YML config, give the wrong instructions? Or did the body, the runner, lack the resources or environment to execute the correct instructions? Understanding that architectural split lets you diagnose automation failures quickly and effectively.
That makes a lot of sense.
And the execution itself follows a specific hierarchy, which defines the process flow.
Okay.
The overall automated process flow, triggered by events like an MR update, that's the pipeline. The pipeline then moves to defined stages.
Stages.
Stages are sequential groups that organize related jobs. For instance, a very common pipeline would have 3 stages: build, which compiles the code; test, which runs all the automated checks; and deploy, which pushes the application to a server.
And those stages have to complete in order, right? The tests won't run until the build successfully finishes. They act as sequential gates.
Precisely. And within each stage, you have the individual jobs. Jobs are the specific tasks that the GitLab runner executes. A job might be running unit tests, or compiling the application code for a specific architecture, or uploading an artifact to storage.
I see.
The hierarchy is clear. Pipelines contain stages, and stages contain one or more independent jobs. Mastering that 3-tier execution hierarchy is paramount for writing effective CI/CD.
That deep dive into CI/CD is so critical because that's the technology that separates modern development from older systems.
It really is.
So finally, let's quickly round out the ecosystem with a couple of key auxiliary tools that support collaboration and system integration.
We have 2 essential supporting tools that round out the platform. The first is wikis.
Right, for documentation.
Exactly. Wikis are crucial for maintaining documentation and internal knowledge sharing, the stuff that isn't code. They live right alongside your project, allowing teams to maintain architectural diagrams, onboarding guides, or decision logs directly within the ecosystem.
Super accessible.
Very. And the second, which enables integration with the outside world, is webhooks. We mentioned these briefly, but they deserve a clear definition. Webhooks are the mechanisms used for system-to-system communication.
Can you give us a concrete example of a webhook in action? Because system-to-system communication can sound a little vague.
Absolutely. Think of a webhook as an automated notification trigger. Let's say a pipeline fails in your project.
Okay.
You configure a webhook to listen for the pipeline failed event. When that happens, the webhook immediately sends an HTTP payload, a burst of data, to an external service, maybe a monitoring dashboard or a dedicated Slack channel.
Oh, right.
This allows your external communication or monitoring tools to react automatically and instantaneously to critical events happening inside GitLab.
We've successfully navigated the core language of this ecosystem. We moved from the foundational organization, understanding why groups are so much more than folders due to permission inheritance, to the planning scope, differentiating between tactical issues and strategic epics. And we wrapped up by dissecting the CI/CD engine, establishing that necessary split between the configuration brain and the execution body, the runner.
And that focus on why these terms differ is what provides the foundational language you need to read any documentation or enter any team meeting and immediately understand the context.
Yeah.
Knowing the level whether an element is group scoped or project scoped is the key to applying GitLab correctly. You need to understand how the structure you choose affects the entire workflow, from security controls all the way to reporting granularity.
So what does this all mean? It means you now have a clear, structured way to think about the entire GitLab ecosystem, ready for an assessment or your next ramp-up project. You know the brain from the body and the fork from the branch.
I'll leave you with this final thought to mull over. Consider how the required definition for a runner, an agent that executes tasks, fundamentally defines the boundary between configuration, that declarative YAML file, and action in any scalable automation pipeline.
That separation.
That separation is intentional. So think about your own technical workflow. Where else do you see this brain versus body relationship playing out, where the configuration is separate from the execution agent, and what does that separation gain you in terms of reliability or security?
Food for thought. Thanks for joining us for this deep dive. We hope this has prepared you for whatever technical challenge comes next.